Hello dear students, this is Alok sir. Hope you all are fine and enjoying your studies. This is the next video on the chapter light. I have prepared two more videos for the same chapter, so you must go through those videos if you have still not watched those videos. In this part, I will explain formation of images by concave and convex mirror and explanation of ray diagram and uses of spherical mirror. In previous part, we have studied three special rays which are used in the formation of ray diagram, and we also have seen that when object is placed at different places in front of a concave mirror, image is formed at different places. So we will put the object at different places and see the nature, size and position of the image. First, see when the object is at infinity. Object is at infinity, so the rays are coming from infinity, and when it will incident on the mirror, it will reflect and passes through focus. This is the focus rule. We have studied this rule in previous part. So the rays are intersecting at focus. The focus will be position of the image. So when the position of the object is at infinity, position of image is at focus. Size of image, as we are seeing in the diagram, it is extremely small, that is point size. Nature of the image, which is real and inverted. I have also explained real image and inverted image. Real image is what? It is the result of actual intersection of light rays. An inverted image which is forming below the principal axis, that is downward from the principal axis. That image is called inverted image. These are the explanation of real and inverted image, which I have also explained in previous part. So put the object at different place now. When the object is at beyond 2f or beyond center of curvature. This is the mirror, see the ray diagram. This is the mirror and this is pole of the mirror, this is focus of the mirror, this is center of curvature of the mirror. And AB is the object which is kept at beyond center of curvature. We will use the rules, that is when rays are coming parallel to the principal axis, it will pass through focus after reflection. And second one is that when the ray passes through center of curvature, it retraces its path. So these are the rules, and we need at least two rules for the intersection. So two special rays we have taken, and it is intersected at point between F and C. So this is the position of the image. AB is the object and A dash, B dash is the image. So when the object is placed beyond center of curvature, image is in between focus and center of curvature. Size of the image, it is smaller than the object, as we are seeing in the diagram. Nature, it is real and inverted. Now next one is that when the object is at center of curvature. See, we are bringing the object closer to the mirror. First it is at infinity, second is at beyond 2f, and third it is at 2f. So when the object is at 2f or at center of curvature, using the rules, one ray that will come from parallel to the principal axis, it will pass through focus after reflection. Second is that when the ray passes through the focus, it will become parallel to the principal axis, and this is the point of intersection. So AB is the image, A dash, B dash is the AB is the object, and A dash, B dash is the image. So we are seeing that image is forming at the same place where the object is kept, and size of the image and size of the object is same. So when the position is at center of curvature, position of image, that is it is also at center of curvature. Size of the image, it is equals to the size of object. Nature, again real and inverted. Concave mirror always form real and inverted image except one case, which we will see further. Next is that bring the object more closer, that is now it is kept between F and C. So when object is between F and C, position of object, put the object between F and C, this is the object AB. The ray comes from the object parallel to the principal axis, it will pass through the focus. Second, the ray which passes through the focus, it will become parallel to the principal axis, and this is the intersecting point. So the rays are intersecting beyond center of curvature. Position of object is between F and C, that is between focus and center of curvature. Position of image is beyond center of curvature, as we are seeing in the diagram. Size of image, it is larger than the object, and nature, it is again real and inverted. Now bring the object more closer to the mirror. Put the object at focus. This is the mirror, see the ray diagram. This is pole, this is focus, and this is center of curvature. The object is at F. This is the object. Using rules, one ray will pass through the focus, and second, the ray which will pass through the center of curvature. So these two rays become parallel and image will be formed at infinity. So when the object is at focus, position of image is at infinity and size of image is larger, it is again real and inverted. And the last one, when object is between F and P, this is the very special case. That is when object AB is placed between focus and pole of the mirror. As we are seeing that the ray which will incident and the pole reflected with the same angle, and the ray which is coming parallel to the principal axis will pass through the focus. And we are seeing from the ray diagram that both the rays are going far apart from one another, and when we will produce the line backward, we will see that these lines are intersecting imaginarily at a point, means there is an apparent intersection of light ray. So this is the position of the image. AB is the object and A', B' is the virtual image, means in this case actual intersection is not taking place, only virtual intersection is there. So image will be virtual, and also we are seeing that the image is upward from the principal axis, above from the principal axis. So this is the case of virtual and erect image. So when the position of object is between focus and pole of the mirror, position of image will be behind the mirror, as you are seeing in the ray diagram. Size of image, it is extremely large, and nature of image, it is virtual and erect. This is very special case of concave mirror. These were the ray diagrams. When the object is placed at different places, image is forming at different places. Now see what is the case of convex mirror. It is in convex mirror when the object is at infinity, and secondly when the object is kept any place, that is anywhere in front of the mirror. See one by one. When the object is at infinity, the rays are coming from the infinity parallel to the principal axis, incident on the mirror, then it is refracted. But if we produce the rays backward, it appears to be coming from focus. This is the virtual image, means actual intersection is not taking place. So F is the position of image. Size of the image is very small, extremely small, and nature is virtual and erect. In case of convex mirror, always virtual and erect image is formed, and when the object is at infinity, image will be formed at focus. Either it is a convex lens, convex mirror, or concave mirror. See the second case. It says that when object is placed anywhere in front of convex mirror, it forms the image of the object between pole and focus, between pole and the focus of the mirror, and size of the image is always smaller than the object. So when the object is placed anywhere in front of a convex mirror, position of image is fixed. At any situation, position of image is fixed. That is, always image will be found between pole and focus of the mirror. Size of the image, it is always smaller. In case of convex mirror, image will always be smaller. Remember that. Nature of the image, it is always virtual and erect. You also remember that. This is the case of image formation or ray diagram in convex mirror. Now see what are the uses of those mirrors. Uses of spherical mirrors. First, see the uses of concave mirrors. Concave mirrors are used by ENT doctors as head mirrors. This mirror is strapped on their head, which focus the light on the throat or ear of the patient. What are ENT doctors? ENT doctors, the doctors who examine ear, nose and throat. Ear, nose and throat. So they use concave mirror as a head mirror. This mirror focus the light on inner part of the ear and throat of the patient. Secondly, it is used by a dentist to get magnified image of the teeth. And third, concave mirror are used in torches and searchlights as a reflectors. Fourth, concave mirror is used in ophthalmoscope, which is used to examine the eye of a patient. Ophthalmoscope is a device which is used to examine the retina of the eye. So these were the uses of concave mirrors. Now uses of convex mirror. Convex mirrors are used as rear view mirrors of vehicle to see the traffic behind the roads. So it is used as rear view mirrors. Telescopes are made by using convex mirror of suitable curves. That is, convex mirrors are taken to make the telescopes. Third, it is used as reflector on street light to diverge the light in wider area. Means convex mirrors are diverging mirror, so it is used in street light. It diverges the light in wider area. And the uses of plane mirrors. Plane mirrors are very simple mirrors which we use for dressing up, combing, and it is also used for shaving the beards. And one more important use of plane mirror is that it is used in periscope. Periscope is a device which enables us to see the overhead object that are not directly in the range of our sight. Periscope is used in submarines. So these were the uses of the spherical mirror. I have completed this chapter, that is chapter light, in 3 parts, 3 separate videos. You must go through all the videos and see the explanation. Enjoy the video and stay tuned.